Okay, today we're starting Unit 7, and this unit is mostly about triangles, characteristics, and working with them. So the first thing we need to do is make sure that we know how to classify triangles. And we're going to be classifying triangles by their angles and by their sides. So a couple of things to keep in mind is that if all three angles are acute, we call it an acute triangle. If we have one obtuse angle, it's an obtuse triangle. The other two angles will be acute. If we have one right angle, it is a right triangle. The other two angles will be acute. And then if we have three congruent angles, if all of the angles are equal, we call it equiangular. Okay, equiangular. So that might be a word you may or may not have heard before. These I know you have. Okay, so if we look here at this big diagram right here, the thing you need to keep in mind is we're talking about different triangles. So triangle CDE is just this triangle right here, and you can see that it is a right triangle because of the right angle. And then ACE, that's this one here. Okay, this is ACE, and you can see that we have one obtuse angle. All right, we have ABE, that's this one. This is our equiangular. So you can see this triangle here has all three angles are the same. All right, and then the next one, BDE. So here's B, and then D, and then E is over here. And we're actually just talking about this piece of E. I know that E looks like it has four different things going on, and it does, but it's not just a right angle. Okay, so we've got this part here, and this part here. That's an obtuse angle. So you've got that triangle right there. The big one would be BDE. And then we have, let's see if I can do this. I have this triangle here and this triangle here, and so we're cutting off a little bit of the 90-degree box. We've got two other acute angles, so that is an acute triangle. You'll need to be able to classify angles according to, or classify triangles according to their angles. You will also have to classify them by their sides. 3 sides is equilateral, 2 congruent sides is isosceles. Okay, and I kind of think about it this way. I've got 2 S's here, and I've got 2 E's here, with a letter in between. It's kind of how I keep that. And then scaling. Okay, each one of these is a different number. Okay, scaling triangle, no congruent sides. All right, so then we have this triangle here. Something to keep in mind is that these are marked for you. These are marked for you, but these 2 sides here are not. So just for reference, I put 3 marks and then 4 marks, just because they're not the same as the others. And then you can see that the big triangle, JKM, so I've highlighted that big triangle here. All right, this side is 1, and then I've got this mark of 2 and 3 on the sides, and then this is a 1 and 4. Okay, so I've got all these different sides. They don't have any congruence to them. I have congruent pieces, but not the whole side. My pink triangle here is isosceles. You can see that with these 2 sides being congruent. And then finally, the green triangle is equilateral because I have all 3 sides having a congruent symbol, meaning they are all the same measure. Okay, you do need to be able to name a triangle by sides and angles. Okay, so both of them, kind of like a first name and a last name. So what I tend to do is I put the angle first and the sides second. And that tends to be pretty standard. So I always look at the angle, then the sides, and write them down in that order. I've got a right and then isosceles. So a right angle, isosceles, sides, right isosceles. Obtuse angle, none of these sides have anything on them to say anything about congruence. So this will be an obtuse scalene triangle. Equiangular, equilateral. And what you'll find is that equilateral triangles are equiangular. In fact, their angles are always 60 degrees. Number 12, I have 3 acute angles, and I also have 3 different sides. So we have acute scalene. Number 13, I have a right angle, but then I have 3 different sides, so a right scalene. And then for 14, I have an obtuse angle and isosceles for my sides, so that is an obtuse isosceles. Okay, be able to name by sides and angles. On the next page, you will do 1 through 9 on your own. Okay, so 1 through 9 on your own, and I do recommend, you know, that you notice like these are the same here, and then if this is 7, how much is this? We've got a 5 here. You can see a 19 and an 18. And then, okay, if this is 60 and this is 90, then that has to be also 30. Okay, got 90 on this side. So you should be able to figure everything out. So in number 9, you are classifying by angles and sides. So it'll have 2 names for each of one of them. Okay, same thing on 1 through 8. And then let's talk about number 10. We are not going to draw this and measure it. We're not going to graph it. We're basically going to use distance. And that distance formula from Unit 1. Okay, so let's talk about DE. Let's do DE first. So I have 8 and -6, and then -1, -3. Now the thing with distance is the distance formula is x2 minus x1 squared plus y2 minus y1 squared. But what I find is that quite a few of you get lost with all of the positive and negative signs. There's a whole bunch of different signs. So basically what I look for is I want the difference, or I want the distance from one x to another x. How far is that? And then I do the same thing with my y values. I look at, you know, this y value and this y value. How far is that? And I just use distance, and then I don't have any negatives. So let me show you what that looks like. All right, so here is x1 and x2. If I go from 8 down to -1 on a number line, that is 9 units. Okay, and then for my y values, if I'm at -6 and I go to -3, that's only 3 units. These two numbers are super important. I literally can just put them in my radical. I can have 9 squared plus 3 squared. Okay, and then this whole thing right here, this piece can get put into my calculator. So this is a lot easier than this. All right, otherwise I would have -1 minus 8, and I would have -3 minus -6. So that's a lot of things to write down and keep straight. I think it's a lot easier just to rely on distance. And then this becomes square root of 90, or if you're using the white calculators, it will reduce that for you, 3 square root of 10, which is approximately 9.5. Okay, so that's one side of the triangle. And then I'm going to go from E to F. I'm going to do the same thing, -1, -3, -2, and 5. Okay, so from -1 all the way to -2, that's only 1 unit. From -3 to a +5, that's 8. And so D equals, well, we're going to have 1 squared plus 8 squared. We're going to stick that in the calculator, the whole thing here with the radical symbol, the square root symbol. And that'll be square root of 65, which is approximately 8.1. Okay, when I'm just rounding to the 10th, please round carefully. And then we have DF. So this will be 8 and -6. And here is -2.5, so that's F. Same thing as before. From 8 to -2 is 10 units on a number line. And -6 to +5 is 11. All right. And this equals 10 squared plus 11 squared. All right, this will turn out in my calculator to be the square root of 221, which is approximately 14.9. And after that, you can then see, okay, these are all different distances. You could also just look at the radicals and see that those are different. And so we know that this is a scalene triangle. Okay, so unit 1, distance, is going to keep coming back over and over and over. I'm going to stop this video and I'm going to make a second video for the next piece. So I will see you in a moment.